Today's topic of conversation is skeletal modeling using the tool of Autodesk Inventor. We'll flip over to Inventor, and where we have a saddle assembly containing of a section of a tank with all the supporting cast, where we have ribs, an end plate, and webbing. Today's topic again is skeletal modeling, so let's take a look at our master sketch. Here we have a single part file that contains the sketch profiles of all the components that compose this assembly. What you'll also notice is that we have all the parameters that will drive the shape, size, and location of all the individual components. Keep this in mind. We will return to this shortly to show some work that we've done. Let's clear the visibility of our end plate and let's build it from scratch so you can see how to use skeletal modeling in your environment. We're going to create a component in the context of the assembly, call it end plate, and constrain it to the XY plane of the assembly. Now, without sketching a thing, finish the initial sketch, and from our Manage tab, access the Derive Component tool. We're going to pull in the master sketch part file, which allows us access to not only the sketch, but also those driving parameters we just looked at. We'll now have the profile for the end plate that we're building, and with the extrude tool we're going to be able to again grab the parameters from that initial sketch file. We'll finish this part up by adding in the tapered edges that require the profiles for the removal of material. Let's dimension across the horizontal, and let's access those parameters again to get our dimension. We'll cut out the unnecessary material, and once again we'll pull in parameters. We now have the part. Let's take it to the top level, finish constraining with a couple flush constraints. What you'll notice is that using the skeletal modeling technique, all of your constraints derive around the origin of the part to the origin of the assembly. We now have the end plate in question, fully constrained. If you'll take a look underneath our model tree, you'll notice that the master sketch part file is embedded within each one of the subsequent parts. Let's see why that is effective. Let's edit that file in the context of the assembly, go straight to our parameters, and make some geometric changes. We're going to go from a 99.5 inch OD for our tank to a 95.5. We'll grow the overall width of our product to 30 inches. We'll bring our rib spacing, which are our blue components, down to 16 inches. Let's take a look at the end plate location by changing it up to 140 degrees. And the length of our actual section of tank will go up to 160 degrees. We'll put our webbing length at 34 inches. When we return to the top level assembly, notice that the model will update accordingly. Turning the visibility of our master sketch file off, you can see that we have a much larger assembly, and let's do some inquiries. Let's measure our rib spacing. If you'll remember, we changed it from 18 to 16. The overall width of our assembly is now 30 inches, as we told it. And the overall width of our webbing is 34 inches as well. We'll go back and make one more change just to try to drive the point home. You have one point of influence over your entire assembly configuration. Go to 97.5, 22. Go with some odd spacing here, just so you see it doesn't have to be even numbers. Making changes to multiple parameters, finishing the edit and returning to the top level assembly will indeed update your entire model. So with the master sketch theory, or skeletal modeling as it's called, you embed a single part file into each of your parts of your assembly and have one point of focus for all the changes. Using Autodesk Vault, we can house this assembly inside of the vault, and the next time we want something the same as but a little different, use the copy design techniques to allow us to have easy access to our next configuration. Thank you for joining us. This has been another tech tip provided by Avitech Solutions.